All right, we're going to learn the last piece of hypothesis testing we need for our project, and it's called ANOVA. Okay, so get notebook 22 open and ready to go. All right, and we'll scoot through. What is ANOVA? ANOVA is an acronym that stands for Analysis of Variance, and it's very much like the t-test. The problem with the t-test is that we can only use up to two groups. We can compare two groups. The problem is, what if we have more than that? What if we have three groups or four groups? Um, and this could often happen. I mean, just imagine if we tried to compare racial background or ethnicity. There's obviously a lot more than two groups there. Okay, so the hypotheses for ANOVA often are written in words, and the null hypothesis is that all of the groups have the same exact mean. And what's the opposite of that? The opposite is that at least one group has a different mean. In other words, if a family has four children, the opposite of all four children are girls is not all four children are boys, right? The opposite, if you don't have four girls, then you have at least one boy, okay? So the opposite of all groups having the same mean, the alternative hypothesis is at least one group has a different mean. And we have to do a little bit of hunting and searching after the fact to find out exactly what differences are there. And the code we're going to use is stats.f one way. So with the linear regression, the statistic we calculate is R. And with the t-test, we calculate t. That's the statistic. The statistic in the ANOVA is the F statistic. And also, as with all the other hypothesis tests, we need array data in this one, okay? So, sorry. And let's look at example one. It's about car type and MSG, okay? So I'm going to jump into the ANOVA notebook, which is notebook 22. And we looked at this in the last video. The cars comes from the hybrid.csv. And so notice that we're doing a dot where here and getting cars that are compact SUV or minivan. Those are the classes, okay? And when we do group stats, right? So with group stats, remember this because this will be on the project. We put the name of the table in first. We put the grouping variable in second, and then third goes the numeric variable. So the different classes are what what group stats is using. All right, compact minivan and SUV. Okay, and notice that there are some mean differences, right? The averages here are 26 and 43 and 49. I didn't round exactly on that, but you can see there seem to be rather significant differences. Okay, so what do we do? So this is a good start. Group stats is a good start to kind of see what the averages are for the three different groups. Now we're doing where class is compact dot column MPG. So once again, hypothesis testing requires array data, not table data. So the first thing I've got to do is I've got to create an array for each of the classes. So I have the first one is compact, then for the class minivan, which is second, again, dot column MPG, gets me array data for the minivans, and then I can do SUVs last, dot column MPG. So this is going to get three arrays, and then stats.f one way. So what do I do here, right? I just put in the names of the three different arrays. Does the order matter? No. No, it does not. You'll notice that we do it in the same order that we created them here. But the order doesn't matter. You will get the same p-value regardless of the order that you put them in. Okay, and what p-value do we get? Well, let me get rid of the ink and run this cell, make sure that we're up to date. The p-value is 3.6 times 10 to the negative 18th. Okay, times 10 to the negative 18th. So the scientific notation at the end means that we have switched, right? The e to the minus 18 means that we've switched to scientific notation, which means this p-value is very, very, very close to 0. And since p is less than alpha, less than 0.05, we reject the null. What's the null? The null is that, hey, all the means are the same. And we can reject that. We have evidence for the alternative, that at least one, the fuel mileage in at least one of the three types of vehicles is different. Now, all three of them may be different, or two may be different than the other. We don't know exactly what's going on, but we do know that. So let's jump back into the notebook and get rid of the ink. Okay. And this is why in the notebook we go back and we do t-test independent. So remember, this is the two-sample t-test, and the IND stands for independent samples. That means the assumption is that you can't simultaneously be in both groups. You're either a compact car or a minivan. You can't simultaneously be both. Okay, and why are we running these? Well, the p-value is bigger than 0.05, so we don't find a significant difference between the compact and the minivan, but we can check between the compact and the SUV. Notice we end up with scientific notations. This is close to 0, so we do find a significant difference here. And then comparing the t-test independent between the SUV and the minivan, once again, we get scientific notation. Always remember to check the end of these numbers, right? This one did not switch to scientific notation, but the second two did. So we have evidence of a difference between the SUV and the two other types. But we don't have an evidence of a difference between the compact and the minivan. And if you want to scroll back up, you can see the compact and the minivan were both in the 40s. Okay. And the SUV was down in the 20s. So we're finding a significant difference between the SUVs and the others. And when they report that out, again, our p-value is less than 0.05, and they're actually making the point that it's very small. P is less than 0.001. Therefore, the difference in the SUVs and the other two is statistically significant. Okay. And this is a box plot showing what's going on here. Right, so we didn't find a difference between the first two, between compact and minivan, but we did find a significant difference between the SUVs and the other two groups. Okay, and here are all the formulas, how to calculate the F statistic. And do you need to know all of this? No, you don't. We're going to use the computer to do all that calculation for us. Okay, and it does have a picture of this F distribution. And here they're saying that the line where we draw and then shade to the right of it in red, it was such significant evidence for a difference that we can't even see the shading. Okay, so now we have a new data called students. And let's see what the question is here. Hours of sleep by year in college is one of the checks, and then we're also going to look at fuel mileage by class of truck. Okay, good. So the first thing they're doing is setting this up. So we said college students, that's the name of the table, students. We're going to see if freshmen, sophomore, juniors, and seniors get different amounts of sleep hours. Okay. So notice that the college year is either first, second, third, or fourth. We don't have freshman, sophomore, junior, senior. We have first, second, third, and fourth. And the group stats, remember, you put the table name first, the grouping variable second, and the third thing that goes in is the numeric variable. Okay, and look at the means. The means are averages for hours of sleep. So freshmen get about 7.4 hours, and seniors get about 7.2, a little less than 7.2. And notice that sophomores and juniors both get about 7.37, 7.38 hours of sleep. So there's not a huge difference between first, second, and third, but the seniors do seem to be getting a little less sleep. And so what do? Remember, we need array data. So these freshmen, sophomore, junior, seniors, these are arrays. What do? We take the table name, which is students, and we do a dot where to get the freshmen in this case, and then dot column sleep hours. And then everything is the same except for the second row is sophomores, and the third row is juniors, and the fourth row is seniors. Okay, and we run this. And notice that the p-value is not less than 0.05. Okay, the p-value is a good bit bigger than 0.05, which is our standard alpha. Why am I saying that? Well, because we're going to fail to reject the null. We have no evidence of a difference in group means. And you'll notice that at least with the freshmen, sophomores, and juniors, of course, they're very, very close, between 7.37 and 7.4. The seniors looked a little lower, but again, even though they were a little bit lower than the other three groups, there's not a significant difference here. Okay, and so that's how we conduct this ANOVA hypothesis test. We need to do something like group stats to see if there are, to look for associations. Are there differences in these group means? Okay, then we have to create an array for each of the groups and then put the names of the arrays in stats.f one way, that function. Okay, and again, this is going to be used, the ANOVA is going to be used on the project, and details about the project will be forthcoming tomorrow.